So good afternoon, everyone, or good morning or good evening, depending on where you are in the world today. Thank you so much for joining us for our session, and we'll get started in just a few moments. In the meantime, I'm very much looking forward to what your response is for our first poll question. Stay tuned. And here we are with 55% looking to operate a UAV, 4% to operate a manned aircraft, and 41% of you guys are looking to operate a lightweight RIEGL LiDAR system on both the UAV and a manned aircraft. Until about 2 o'clock, it was about a 50-50 split between UAV or both the UAV and manned aircraft, absolutely 0% for a manned aircraft, until about 2 o'clock, and then it completely switched over and a higher percentage started logging UAV only. It may have to do with the title of today's presentation. Hi everyone, my name is My-Linh Truong, and a little bit about myself. I've been with RIEGL for nearly 10 years, wearing a lot of hats over that time frame. First, diving a little bit into LiDAR data processing, and then transitioning over and taking over the training and support department, managing that for kinematic systems. And with the emergence of the commercial UAS marketplace, I finally made my transition over to my current role, which is our unmanned laser scanning business segment manager for North America. Joining me today is my colleague, Stephen.
Good afternoon, everyone. To briefly introduce myself, I've been a team member with RIEGL USA for nearly 2 years now, originally starting my time with the company in support similar to My-Linh. My time working with RIEGL USA support, assisting customers, taught me the ins and outs of RIEGL hardware and software, and I've taken that knowledge and experience forward with me in my current role as a ULS technical sales and integration representative.
Today, Stephen and I will be presenting on the benefits and highlights of the RIEGL VUX series UAS LiDAR scanners and systems. Now, before we start, I just want to make note of at the bottom of your screen is a question box. Please feel free to add your questions during today's session, and we will do our very best to answer them all at the end. So why UAV-based LiDAR? The ability to make use of LiDAR on a UAV platform offers the end user all the benefits of operating LiDAR, which is an active sensor by using light, aka lasers, in this situation. And because it's using lasers and light, it gives the ability to use the system in various lighting or weather environments, including low ambient lighting conditions or even at nighttime, which is an environment where photogrammetric data collection is just not successful in. Now, of course, for UAV operations, you'll obviously need the appropriate permissions to operate in that environment. In this smaller aerial package compared to manned operations, it offers a lower upfront investment, as well as your mobilization costs for data acquisition. RIEGL is a leading and established LiDAR manufacturer that provides engineering and survey-grade accuracies for a multitude of UAS applications. Specifically, we provide dense, accurate, and feature-rich data, and these applications and use cases will be featured later on in today's presentation. In addition, we offer efficient and precise data capture based on our streamlined data acquisition and post-processing workflow. Although the commercial UAV market really emerged and developed over the past several years, RIEGL's unmanned technology has developed a long line of UAS-specific sensors, establishing a historical foundation over the last 15 years. Although the first RIEGL UAS sensor was released in 2005, the frequency of new developments were sparse, a new release every few years, given the demand at the time, using larger aircrafts. However, with the introduction of the then named VUX-1 in 2014, it is this compact and lightweight UAS scanner that really set the stage as the commercial UAV industry began to grow exponentially. The VUX-1 was later renamed to be the VUX-1 UAV, and it is this scanner that has truly built the foundation of RIEGL's UAS LiDAR product family, with further developments established every year since then. Next, Stephen will dive in and describe the VUX-1 UAV more in detail.
The foundation of the VUX series, the VUX-1 UAV is a lightweight, survey-grade accurate LiDAR sensor that weighs in at 7.7 pounds or 3.5 kilograms. Over the past 6 years, the VUX-1 UAV has met industry's demand for UAV-mounted LiDAR, providing users the capability to capture point clouds in hard-to-access regions while reducing operational costs when compared to manned airborne LiDAR systems. As the VUX-1 UAV moves about a project site, it creates scan lines that reflect off objects and return back to the sensor like you've just seen in this animation. These scan lines are generated by the pulsing of the laser source onto a rotating mirror internal to the VUX-1 UAV. For the VUX-1 UAV, this mirror can rotate up to 200 revolutions per second, resulting in tighter scan lines and denser point clouds. The VUX-1 UAV's 330-degree field of view also allows for users to plan for wider flight lines, reducing the amount of time required to capture a project site. A firmware upgrade is also available upon request to increase your field of view up to 360 degrees. Here we look at a cross-section of a point cloud that displays the VUX-1's ability to penetrate vegetation and acquire pulse returns from the subsurface. In terrain modeling, getting these ground points are crucial in making accurate elevation and slope approximations. The way the VUX-1 UAV is able to penetrate vegetation this successfully is because of its ability to identify up to 15 targets per laser pulse. After the laser pulse is emitted, it begins to diverge, increasing the diameter of the laser pulse. As this laser pulse diverges, portions of the laser pulse may come in contact with vegetation and reflect back to the sensor, while other portions of the laser pulse travel to the ground unobstructed and reflect back to the sensor. With the VUX-1 UAV capable of emitting 550,000 laser pulses per second, you can have the confidence that you will be able to penetrate even the thickest vegetation. Here are a couple of contour graphs showing the VUX-1 UAV's performance at 550 kilohertz scan mode. The contour graph on the right shows us the relationship between your UAV's ground speed, altitude, and point density of your data. The example given shows that when flying at 100 meters AGL at 6 knots, or roughly 9 miles per hour, you can expect your point cloud density to be around 200 points, give or take, per square meter. I also want to bring to your attention the graph on the left, and you will see that the maximum measurement range for the VUX-1 UAV is dependent on the reflectivity of objects within your project site, as well as your aircraft's altitude. The more reflective an object, the greater the maximum measurement range. Now let's look at a comparison between the VUX-1 UAV and the VUX-1 LR. Larger projects that range on from tens to hundreds of miles usually mean a small UAS won't cut it, with some contracts even requiring the data be collected from a manned helicopter. Because of this demand in the marketplace, RIEGL has developed the VUX-1 LR. The VUX-1 LR will allow your data acquisition team to fly at higher ground speeds and altitudes, reducing your time for data collects while maintaining the same weight and dimensions of the VUX-1 UAV. Looking at the VUX-1 LR's performance at 820 kilohertz reduced power, we see that the point cloud density stays similar to the VUX-1 UAV while allowing for an increased ground speed from 8 knots or 19 miles per hour up to roughly 30 knots or 67 miles per hour. Now we look at the VUX-1 LR's performance in the 600 kilohertz mode. You'll notice in the example given in the contour graph on the right that your aircraft ground speed has increased significantly, up to 60 knots or roughly 134 miles per hour. And at an AGL of 150 meters, your point density is 20 points per square meter. This is the trade-off that you get when traveling at higher ground speeds. You lose resolution, however, you can capture data in your project area at nearly 10 times the speed compared to the VUX-1 UAV integrated onto a small UAV.
Thanks so much for that overview of the VUX-1 UAV and the VUX-1 LR scanner, Stephen. With the increase of beyond visual line of sight efforts, we've expanded the internal data storage capabilities for the VUX-1 series. All VUX-1 units are now being delivered with 1 terabyte of solid-state storage drive space. And in addition, we've modified the back panel where the scanner itself can support up to 4 camera interfaces directly. If 4 cameras are not enough for you, we also offer a 5th camera interface by making use of the provided cable and the connection board light and its corresponding camera port. In addition to that, we also offer an alternate data storage capability with the VUX-1 UAV or LR integrated with the Applanix APX20 IMU, and it is this housing structure that offers a compact flash card that enables the end user the ability to hot swap your data storage while you're out in the field. Due to the increase in demand for longer ranges and a higher point density requirements for your projects, the introduction of RIEGL's VUX-240 has truly taken the world by storm. Although it's larger and slightly more in weight compared to the VUX-1 series, it is this compact aerial scanner's capability that is double that of the VUX-1 LR at a maximum 1.8 megahertz, which is 1.8 million laser shots per second, and it's the concentration of these points within a field of view of 75 degrees. It's with these specifications that this scanner offers your user the one pass and done aspect to data collection, and it's with the 1 terabyte solid state onboard data storage that truly opens up the market for beyond visual line of sight UAV applications. For UAV system integrations using Applanix's APX20 IMU, we support the integration of the Sony a7R III camera, as well as Phase 1's IXM 50 or 100 RGB cameras. Here you can see it being flown on RIEGL's Rycopter UAV solution. In the data screenshot seen on the right, you can clearly see how well defined the transmission tower or the pylon is captured from the Rycopter. This offers a fantastic LiDAR solution for power line or corridor mapping applications. Let's investigate further with another data acquisition example at the highest pulse repetition rate of 1800 kilohertz or 1.8 megahertz. If we're operating the UAV and flying at 10 meters per second, which is approximately 22 miles an hour or 20 knots, and operating the UAV at 90 meters above ground, this yields an average whopping number of 1,000 points per square meter. This is one flight pass, guys. Alternately, if we use the same flight condition example as Stephen presented with the VUX-1 LR at 600 kilohertz, again flying at 60 knots, operating the aircraft at 150 meters above ground, this yields an average of 60 points per square meter. In comparison with the VUX-1 LR, that same example offered 21 points per square meter. This is showing that in this example for the VUX-240, it's 3 times the point density just from the same flight operations. When comparing all 3 of the VUX LiDAR scanners, the key difference is really the trade-off on the amount of laser pulses that are coming out of the scanner, the pulse repetition rate, as well as the accuracy. And when comparing all 3 scanners, I would really assess that it really depends on what your ranging needs are for your operation, whether dedicated small UAS, 41% of you are saying both UAV and manned. You're looking for something that gives you that flex dual usage for your quicker return on investment. Once you've selected your LiDAR scanner, there is, of course, the optional camera system. I did mention that a little bit briefly a few slides ago, and it's that camera imagery that adds the data fusion, and allowing the additional attribute information, your RGB information. For UAV integrations, we really offer 1 to 2 cameras, which depends on your available payload space that you have available on your aircraft. And of course, the positioning is related to the weight and balance of the overall payload. For 1 camera or a nadir configuration, this is really good for orthophoto mosaic creation because it's that downward look orientation. However, the footprint of the camera does not coincide and match the field of view of the 360-degree field of view scanners that we offer. However, it is perfectly suited for the more reduced or limited field of view scanners like the VUX-240. Alternately, for an oblique orientation camera configuration, with the merger of the 2 cameras, this offers a larger swath and increases the effective area of coverage of the camera images, which therefore means that you have a more efficient workflow for your data colorization. However, because of the oblique orientation of the cameras, it may yield a little bit more difficult when creating those orthophoto mosaic creations. Depends on what you're looking for, and something to take into consideration. For the VUX series, we do offer quite a few different cameras. We offer the A7R3 camera, as well as the A6000, whereas the A7R3, circled on your right, is double the megapixels. For the Phase 1 IXM 50 or 100, it is this camera and the offered lens size that is perfectly suited to fit the footprint of the VUX-240. And for those needing thermal imagery, we also make use of the FLIR Tau 2, and because of its small size, this camera can be offered in conjunction with the other RGB cameras that I mentioned.
Now let's check out RIEGL's helicopter pod, the VP1 pod that was designed for VUX series sensors. The VP1 pod's protective external housing not only reduces the amount of exposure to your system as you operate, but also gives the VP1 pod a professional appearance. The VP1 pod is also capable of being compatible with your helicopter's flight management system, streamlining the interface between LiDAR operator and LiDAR sensor. If an onboard flight management system is not installed on your helicopter, RIEGL has options to purchase a third-party flight management system or a pre-configured onboard acquisition laptop. With minimal external cabling to run, the VP1 pod's adapter plate being compatible with industry-known Meeker mounts, the VP1 pod offers a straightforward installation that looks professional and clean. Quick release brackets and easy to access cable connection box allow for users to mount and dismount the VP1 pod with ease. RIEGL has also recently made available the VP1 pod configuration for the VUX-240, providing an integration solution for one of the many airframes that the VUX-240 can effectively operate on. In the image on this slide of the VP1, you will notice 2 circular openings on the bottom of the pod. Those are for optional Phase 1 IXM 50 or IXM 100 cameras and or a thermal FLIR Tau 2 camera. Now, aside from the VUX-240's VP1 pod's nadir camera configuration for the Phase 1 IXM cameras and the FLIR Tau 2 cameras, shown on the last slide, the VP1 pod with VUX-1 LR integrated allows for a couple of camera options and camera orientation options. Nadir and oblique camera orientation options are available for purchase for the VP1 pod, and those cameras are the Sony Alpha 7R3 and the Sony Alpha 6000. With oblique field of view options ranging from 129 degrees up to 213 degrees.
After this overview of the VUX series LiDAR scanners that are available, how do you decide which one is best for you? Besides the size of the payload, the overall weight, and of course cost, it's really application dependent. It's not a one-size-fits-all, but it can be a one-size-fits-most, as seen on the table on the screen. In the end, it really relates to what weight you're looking for the payload, your ranging capability needs, and the resulting point density required for your projects. For the VUX-1 UAV, last week I presented on the Mini VUX series, and the VUX-1 UAV offers 5 times the laser performance over the Mini VUX-1 UAV. It's still a cost-effective, survey-grade accuracy LiDAR. For the VUX-1 LR, it offers a longer range over the VUX-1 UAV. And it's that ability that gives you the option to operate it in both the UAV as well as manned aerial applications. For the VUX-240, twice the laser performance of the LR, and that makes it truly suited for beyond visual line of sight applications and manned aerial operations. Once your payload configuration's been decided, the resulting calibrated and georeferenced point cloud can then go into any 3D modeling and analytics software, such as Autodesk's software suite like AutoCAD, MicroStation, Bentley application, Esri's ArcGIS using RIEGL's RIMAP web application. This inherently supports all of RIEGL's data outputs when you use our RIProcess data processing software workflow. And it's pulling out these layers of information. You're able to create your digital terrain model, isolate and identify your vegetation, measure the tree canopy height, and with repeat monitoring, monitor the tree canopy change over time. This is just one example for environmental monitoring. For forestry applications, you really need the multi-target capability, multiple measurements per laser shot that RIEGL's LiDAR is capable of, which offers the ability to penetrate to the ground and clearly define all the components of the trees. This gives you the ability to measure the health of the vegetation, the tree canopy height, as I mentioned previously, as well as measure the diameter at breast height, or DBH. For power line applications and utilities, the benefit of a more narrow, concentrated field of view really concentrates all the laser pulses along the corridor. In this application, and showcasing the data from the VUX-240, it's a fantastic ability to model the pylon or transmission towers. For transportation, it really depends on what your needs are. For example, are you measuring your right-of-way? If that's the case, then you're looking for a wider field of view where the UAV is able to get the slope bank angle along the corridor, which is where the mobile LiDAR system is not able to see given its look perspective from the road. In this case, I would say our VUX-1 UAV would make the most sense, as it offers the tightest accuracy of the VUX-1 series. For bridge inspection or critical infrastructure, you need that wide field of view, which allows you to fly along the bridge deck and still get your laser shots under the decking. In this example, I would also say the VUX-1 UAV. For opencast mining, again, wide field of view, the ability to fly along and capture the depth of this open pit mine. And in that case, I would really recommend still the VUX-1 UAV, or more so the VUX-1 LR, because of that longer range and capability. And last but certainly not least, geophysical risk assessment and management. While the RIEGL USA headquarters is in Florida, and it's pretty flat here, minimal risk of landslides, but you can take into consideration measuring slopes of landfills, measuring quarries, and geophysical risk assessment. In these environments, you still need that wide field of view, the ability to fly alongside the rock face and capture the information that you need. And with that, I'm going to change over to our last poll question. Which application do you or your company primarily focus on? Forestry, utility management, transportation, construction or infrastructure, or opencast mining? So it looks like we've got a pretty even split between construction and infrastructure, as well as utility management. Actually, it's pretty well evenly split if you think about it. So looks like we got our work cut out for us today. I'm going to go ahead and close this out. And I really want to thank you so much for joining us this afternoon. And if you're interested in learning more about RIEGL's RICOPTER UAV to form a turnkey UAS solution from one manufacturer, then I invite you to join Stephen and I on Thursday, May 28th, same time, same place. Stay tuned for May's series of webinars. That schedule will be released shortly, and you'll be able to find the registration links for all of May's webinars on RIEGL's newsroom, as well as our LinkedIn. Or you can feel free to email Stephen or myself directly, as well with any questions that you may have. And yes, we will be distributing the recordings of all of April's webinars next week. With that, I'd like to see what questions we have today. All of RIEGL's LiDAR scanners, regardless if they are UAV, airborne, mobile, terrestrial, they all make use of pulsed time of flight laser technology.
Hey, My-Linh, allow me to step in here and answer one of the questions.
Perfect, thanks.
So there was a question posed, is the VUX-1 UAV fixed in MTA Zone 1? The answer to this is no, it is not fixed into MTA Zone 1. RIA MTA software that RIEGL has developed to identify MTA zones is included with the purchase of any VUX series scanner. So to answer your question, your VUX series scanner can operate in MTA Zone 1, 2, 3.
And with that, thank you so much for joining us, and we look forward to working with each and every one of you. Stay tuned for next month's webinar. Thanks, guys.